In this video, we're going to look at what are called polynomials. And so here I have a few pictures of polynomials. You've looked at some polynomials in your math life so far. Some of those include parabolas and lines, but then we'll look at other types of polynomials today. We're also going to talk about some terminology with polynomials, and then we're going to talk about, well, what's happening on the far left and far right of the polynomial. That's called end behavior. We'll get to that in a moment. Okay, so what is a polynomial? Well, let's start with what's not a polynomial, and then we'll kind of look at what's different about polynomials. On the right, in the red, these are things that are not polynomials. So if you have a negative exponent, that is not a polynomial. If you have a square root on x, or any sort of root on x, that's also not a polynomial. Things that would also fall under this category are things like x to the 3/2. This technically is the square root of x to the third. So maybe with roots on x, you might also say that it has a fraction exponent on x. Ooh, that is hideous. Let's try that again. Fraction exponent on x. Or decimal, like you need a whole number exponent for x is what I'm trying to say to be a polynomial. You also can't have x in the bottom of a fraction. That would technically fall under the first category of a negative exponent, but we'll talk about that at a later date. So those are things that make things not a polynomial. You can have square roots in a polynomial equation, just not on x. So like if you have the square root of 8 in your equation, that's okay, but you can't have the square root on x. So these are all examples over here on the left. They're separated by addition or subtraction symbols. These are all separated by addition symbols. So this would be a 3-term polynomial. You've got an x squared, a 5x, and a 7. The second one, instead of writing it y equals, I wrote it f of x equals. And that's fine. You can write it in function notation like this, or you can write it as y equals, like the first one. So this would technically be a 2-term polynomial. The first term is 7x to the 30th. The second term is 5x to the 12th. The last one, I wrote it in function notation as well. It's g of x. And I know there's a fraction here. We said you can't have fractions, but you can't have x in the bottom of a fraction. And you can't have a fraction exponent. But it's okay to have fractions in the equation. In fact, this is a line with a slope of negative 2/3 and a y-intercept of 3. So that would be considered a polynomial. Okay, moving on, let's talk about standard form. If something's written in standard form, then it's written with the largest degree term first, the second largest degree term second, third, and so on. So what do I mean by largest degree term? Well, the degree is the exponent on x. So the largest degree term in this case would be negative 9x to the 4th. So if I'm writing this in standard form, I would write f of x equals, and then I write the largest degree term first, negative 9x to the 4th. And notice that's negative because the minus in front of the 9. Then my next largest degree term would be negative 5x to the 3rd. My next would be x to the 2nd, so that'd be plus 3x to the 2nd. And then next would be minus 8x. And last would be plus 4. So this would be considered standard form if you write it with the largest x exponent first and the smallest x exponent last. All right, I figured we didn't need more than one example to explain that. Pretty simple. All right, and then we have some terminology here. So let's look at the terminology of polynomials based on how many terms there are. In the first example, there's one term. I know it's 3x to the 4th. But what makes it 2 terms or 3 terms is if it's separated with a plus or a minus sign. So the first one is called a monomial. It just has one term. It would be that one term is 3x to the 4th. The next example is called a binomial. That means there's 2 terms, and these 2 terms are 2x and minus 9. If it's 3 terms, it's called a trinomial. Here our 3 terms are 4x, minus 3x, and 6. And then anything above 3 terms, we just kind of call it a polynomial. You're not going to, there's no special terminology for 4, 5, 6, and so on that we're going to use. There probably is, but we're just not going to use it. So in this case, we have a 5-term polynomial. You would just call it a polynomial. Now, technically, also, these 3 things, a monomial, a binomial, and trinomial, are all also polynomials. But we have specific names for those that we use, but they're all still also under the polynomial umbrella. So that's naming them by number of terms. Over here, we name them by degree, which means the exponent on x. So if there is no x, we call that a constant. In this case, it's just y equals 7. You could use any number. It could be a fraction, a decimal, a whole number, whatever. If there's no x, that's called a constant term. For linear, that would be if it's just x to the first. And so in this case, x to the first is the largest exponent on x. We've looked at linear stuff in the past. This would be a line where the slope is 2 and the y-intercept is -5. For quadratic, this would be a parabola. It's x squared. That would be the largest degree. Cubic, now we're getting into kind of new graphs and new terminology. That's when you have x to the third as the largest degree. So even though it has other stuff, you just look at the largest degree. That would be called a cubic. Quartic is x to the fourth. Quintic is x to the fifth. So just some terminology. Basically, this is so that you can speak the language. So if your teacher says something like, this is a cubic trinomial, they'd be talking about something like this. It has, excuse me, I think I said cubic. I meant to say quintic. A quintic trinomial. So this would be 3 terms, and it's a 5th degree polynomial. So quintic trinomial for that one. All right. So let's get into it and practice a little bit. Let's identify the degree, type, and leading coefficient of each of these polynomials. What I'd encourage you to do now is pause, try it on your own, and then hit play and see if you got it right. All right, so I will run through these. The degree on the first one is 2. So if you're asked to just write down the degree, you put a 2. If you're asked to identify what type of polynomial, you would call this a quadratic. The type, there's 2 terms, and so we call that a binomial. And then the leading coefficient. This is not something we've talked about, but basically all you do is you look at what has the largest exponent, which would be x squared, and you look at the number out in front. Coefficient is the number in front, so the leading coefficient is 3. All right, let's look at the next one. The degree here is 4, which means it is called a quartic. The type, there's 4 terms, and we don't have a special name for that, so we're just going to call it a polynomial. And then the leading coefficient here, well, x to the fourth is the largest exponent, and there's no number out in front, and so that would be 1. It's not 0. If it was 0, then there would be no x to the fourth. It's 1. All right, the degree here is 1. There's no exponent on x, so it's not a 0. It's a 1. The type is a monomial. And then the leading coefficient here is a 6. That's the number out in front of x. All right. So let's look at some of the graphs. Look at the shapes of these polynomial graphs, and then we'll talk about end behavior. We'll be done. A lot of stuff in this unit. Okay, so linear, this is an x to the first equation. Lines we've looked at before. If it's got a positive slope, it's going to look like that. If it has a negative slope, it's going to look like so. So this is just drawing on our previous knowledge. Nothing new there. A quadratic is going to be a parabola. If it's a positive x squared, it's going to be a smiley face. A negative x squared, a frowny face. So what you're going to notice here as we keep going down this list, that as the exponent gets bigger, you're going to have one more turn in the graph. And so for a cubic, it's going to be a parabola with another turn. So it's going to look something like that if it's positive x to the third. It's going to look something like this if it's negative x to the third. All right, and we'll summarize here in just a moment. If it's x to the fourth, it's going to look like a parabola with two turns. So it's going to kind of be W-shaped if it's a positive x to the fourth. And then it's going to flip upside down and look kind of like an M if it's a negative x to the fourth. Okay, and then we're going to take that x to the fourth, put another turn in it, so x to the fifth is going to look something like this. And one thing you might start noticing is that the degree is how many times it crosses the x-axis, and we'll talk about that in a different lesson, but that's not an accident there. So what we're going to notice on these, if we just focus on the odd ones we looked at, like x to the first, x to the third, x to the fifth, do you notice that they always start in the lower left on the positives and end in the upper right with the negatives, or on the positives as well, they start in the lower left and end on the upper right. And then with the negatives, I'll switch up colors here, they start in the upper left, end in the lower right. And that's true for all of them. So if we look at just in general, the odds, they're going to start down here, they're going to do some stuff, and then they're going to end up here. And we're going to transition that into what's called end behavior in just a moment, but I just wanted you to notice that pattern for the odds. And then let's do the same thing with the negatives, and so it's going to start up here and end down here. So I don't know what the graph's going to do, but it's going to do some stuff in the middle, but then it's going to end in the lower right. For the evens, kind of a similar pattern. If you look at, let's grab a different color here. If we look at x to the fourth, it points up for both. If we look at x to the second, it also points up on the left and right. And if we look at negative x to the second, it points down on the left and right. Negative x to the fourth points down on the left and the right. So if we're dealing with a positive even degree, it's going to kind of do some stuff in the middle, and then it's going to end pointing up. If it's a negative even degree, it's going to start down below, it's going to do some stuff in the middle, and then it's going to point down. So that's going to be called our end behavior. And let's talk about how do we write this terminology going forward. So let's look at end behavior. Basically what we're going to do is we're going to say as x approaches negative infinity, what's happening to f of x. And I'll write this down and then I'll explain what we're talking about. And then as x approaches positive infinity, what's happening to f of x. So we're going to treat f of x kind of like y. We're going to treat it exactly like y. So when I say as x approaches negative infinity, what I'm saying is we're looking over here on the far left of the graph. What's happening to the graph over on the far left? And if you notice, it's going up. So the graph is going up as we go to the left. Maybe you could write yourself a little note here that this is just saying on the left of the graph. And so what's happening on the left of the graph? The graph's going up. And so the y value is going to positive infinity. The other thing where it says as x approaches positive infinity, well, that's just asking you what's happening on the right of the graph. So what's happening over here? Well, excuse me, what's happening over here? It's going down. And so the graph is going down. That means, and when we say it's going down, we say it's going to negative infinity. And I know that seems a little abstract, but when it says going to positive infinity and negative infinity, that just means it's going up forever or down forever. And so that's where it's heading to. For example, 2, let's write this out, go back to blue. So as x approaches negative infinity, that means we're talking about what's happening on the left, what's happening to y. And as x approaches positive infinity, what is happening to y in this case? So this is over on the right. Okay, on the left, if we look at what's happening over here on the left, well, the graph's going way down. So on the left, it's going down. That means we're going to negative infinity. On the right, the graph is going up, and so we are heading to positive infinity. You're basically just saying if it's going down, that's negative infinity. If it's going up, that's positive infinity. So if you have the graph, you can describe the end behavior looking at the graph. For the last example, what if we're just given an equation or a polynomial equation? So in this case, just think about what the graph would look like. So if I draw a graph here, it's an x to the fourth. We just talked about this. It's going to be a W shape, and it's going to point up on the left and the right. So we would write as x approaches negative infinity, f of x approaches something, and as x approaches positive infinity, f of x approaches something. So this, as x approaches negative infinity, is really saying what's happening on the left of the graph. So what's happening over here? It's pointing up. That means we're going to positive infinity. As x is going larger, so x is going to the right, that means we're looking at the right. It's also pointing up, so the end behavior is also going to positive infinity. This is definitely the most challenging part of this lesson, is understanding this terminology. Obviously, if this is confusing, you ask your teacher, and hopefully they can help you out, or just rewatch this last part of the video. Maybe it'll soak in the second time you watch it. All right, so that is it for polynomials.